Welcome back, everybody. In this question, we have to graph the following two functions. So to graph these, I'm going to use transformations. So starting with this one, we go y is equal to the square root of negative 3x minus 6 plus 2. So first thing I'm going to do is I'm going to factor out this negative 3 because that's going to be the k value. So we could have that x by itself. So we end up with x plus 2 here in the brackets, and then there's a plus 2 outside there. Now notice that the parent function that we're dealing with is the square root function, and it's been transformed. And in general, the way the transform root function looks like is a root k bracket x minus d plus c. So you may want to write this down. So any square root function you run into that's transformed, you want to have it in this format. And then what you want to figure out is what's the a value, k value, d value, c value. Well, this case, it's pretty easy to tell. The a value out here is 1. The k value is negative 3. Then the d value is negative 2. Right? It's always the opposite sign. Then the c value is positive 2. So now what we're going to do is we're going to take the square root of x, that's the parent function. So writing out a couple of points for it, so 0, 1, 4, 9. Those are usually the standard points I use. We got to transform it using the formula x over k plus d, ay plus c. So I got to take all the x values, divide them by negative 3, and then we're going to subtract 2, the d value. Then we're going to take all the y values, multiply them by 1, so that's just y by itself, and then we're going to add 2. So here, 0 divided by negative 3 is 0, minus 2 gives us negative 2. 1 divided by negative 3 is negative 1 over 3, minus 2, that's like negative 2.33. Then we got 4 divided by negative 3, which is negative 1.33, minus 2 gives us negative 3.33. And then 9 divided by negative 3 is negative 3, minus 2 gives us negative 5. To all the y values, we're just going to be adding 2. So we would have 2, 3, 4, and 5. All right, so now we can simply graph this function. We got negative 2 and 2, which is up here. Negative 2.33 and 3, actually it's going to be going this way, so I'm going to give myself a little bit more room in that quadrant. So negative 2 and 2 over here, and if you want to label the point, you could label all these if you want. Negative 2.33 and 3, that would be like here. And then negative 3.33 and 4, that would be like here. And then negative 5 and 5, let's say it's like over here. Not necessarily to scale, but basically the way this function looks is like that. So basically we took the parent function, which is like that. We flipped it in the y-axis because the k value is negative. Then we shifted 2 to the left, 2 up, and then we also horizontally compressed it by a factor of 1 over 3. Right? So that there is the transform function. You may want to make your graph look a little nicer, a little bigger, and then you may want to label all of the points just to make sure you get full marks. Then over here with this function, same thing. The parent function is different. Notice that it's the parabola, so it's x squared. So with a parabola, the transformed form is always this. Like that. So we know a value, in this case, is what? It's negative 1. There's like a negative 1 in there. The k value is 1 over 3, this. The d value is positive 2, and the c value is 4. So we're going to take x squared, the parent function x squared. So let's use a couple points. So -2, -1, 0, 1, 2. That would be 4, 1, 0, 1, 4. And we're going to transform it. And what's the formula that we're going to use? We're going to take all the x values, divide them by 1 over 3. Now x divided by 1 over 3, that's the same as x times 3. It's the same as 3x. We just flip that function, that fraction actually, that we are dividing by, and just multiply. So we'll have 3x plus 2, that d value, and then a is -1, so we'd have -y plus 4, like that. All right, so that's the formula we're going to be using to transform all these points. So -2 times 3, -6, plus 2 gives us -4. -1 times 3, -3 plus 2 gives us -1, actually, again. 0 times 3 plus 2 gives us 2. Then 1 times 3 plus 2 gives us 5. And then 2 times 3, 6, plus 2 gives us 8. Right? And then the y values, we're just multiplying them by -1 and adding 4. So 4 times -1, -4 plus 4 gives us 0. 1 times negative is -1 plus 4 gives us 3. This will be 4. Then we'll have -5 plus 4, or sorry, -1 plus 4 gives us 3 again. And then -4 plus 4 gives us 0. Right? So these are the transform points. And now we could just simply graph these points. Now this parabola, the vertex is going to be at 2 and 4. Notice that this vertex gets transformed to this vertex. So let's put that up here actually, 2 and 4. So that's the vertex. And then we'll have 5 and 3, which would be like here. And then -1 and 3, which would be here. This is not necessarily to scale. Let's maybe actually put this, make it a little bit more symmetrical. So this here is 5 and 3. This is -1 and 3. And then we'll have -4 and 0, which we'll say is here, and then 8 and 0, which we'll say is here. All right, so it looks like that. Right, so we're horizontally stretching this because that k value is 1 over 3. So this point here, -4 and 0. This point here is 8 and 0. And your transform function should always be symmetrical. If your parent function table is symmetrical for x squared, your transform function should be symmetrical. Remember, that's only for x squared, not necessarily root x, because root x is not an even symmetrical function. Right? So those are the two graphs.